what is a guy in a blue sweater coming here, and why is he coming and telling us back to the server? Look, there's going to be a little bit of controversy in this talk. I'm going to be trying to argue that we don't need to push a lot of things to the client when it doesn't make sense. So if you want to insult me on Twitter, _Dino_, it's all yours. Look, I'm no Donald Trump, so I won't insult you back. Hopefully, yeah. I am Alex. I work in Namshi. It's the largest fashion e-commerce retailer in the Middle East with headquarters in Dubai. You can think of it, I think you guys have Zalando here in Poland, right? But regardless, it's Zalando of the Middle East. Like a fashion, like store where people can just purchase shoes, clothing, yada, 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 online. This talk is, I would say, the result of, the combined work by our front-end team. I wanted to just give them a shout out, while I present. If you want to, dig deeper a little bit and, like what's behind, like what we've done, you can have a look at, like our blog tag, namshi.io. We've got like a bunch of things that we've covered there. Now, what I'm gonna, talk about, I would say, we've rebuilt our mobile website 3 times over the last 5 years. And I want to discuss, what were the approaches that we took, and why they failed, and eventually the 3rd time last year, how we decided to approach it, and what were the results of our choice. So first take, it was 2012. Angular was like super hot, so we decided let's build a single page application. It's the best thing we've seen in a lot of time, which pissed Google and whatever bots out there immensely, right? Then Google was threatening to roll out this page is not mobile friendly on the search results. So we're like, okay, this is definitely a downside. And secondly, it pissed clients off. Now you're shipping a whole JavaScript code base to your client, right? And if the JavaScript engine behind it is not like super, I would say, advanced, they are going to have problems running your app. Now, the good thing is I'm talking about mobile in particular here, so we don't really have to deal with IE, but the world, is made of old, crappy Android devices, which have this particular thing that pisses all of us off, the native internet browser. In 2012 it was like super buggy. The HTTP cache spec was like completely broken and so on. So we're like, okay, this thing is like really hard to manage. It doesn't always work the way it's supposed to be. Try delivering a single page app to the native browser. It would just tell you, oh, screw you. So you can do it, but I guess there are ways to do it better. So our second take was like very straightforward. We're like, okay, let's use Isomorphic.js, right? So something that can render both on the client and the server, At that point, it's what, like nowadays you call universal JS. And I really like the universal JS term because it really puts it in perspective. I think it only works in movies, okay? Like the Universal Studios. Now, a couple of years ago, if you want to dig deeper, we presented, like our take to, universal JavaScript applications. And remember, back then it was like 2013, 2014, early 2014 maybe. React wasn't like as big. So, we're just like getting started. And we thought, what are we going to use to, support both rendering, both sides of the rendering. So we built like a very small, custom-made in-house framework. One of the stupidest ideas I've ever had, or ever suggested to the team. And the problem is the clients are still angry because once it's rendered from the server, then you're shipping your full-blown app to the client, and like a slow client, a client that doesn't have like great specs, will still struggle to run that application. And not to mention the fact that we built server-side rendering in React wasn't a thing back then. We built kind of our own thing, and the way it went is like, we start building the framework, everything looks good, we go live, everything sounds, funny, and then everything explodes. So now, probably that wasn't the greatest choice, right? To build everything from scratch in-house, definitely not a smart thing. So, we looked at performance of, for example, our mobile app versus our mobile website, and we're like, look, there's really no match. The app is performing so much better, the mobile website. And you have to consider that we're not just talking about, LTE connections in Dubai. We're talking about, 2, 3G connections in some place some forgotten place in Oman or Bahrain. So we decided, okay, let's do things from scratch. The idea behind it was, okay, let's simplify the code base. We don't want to have this custom in-house thing get running. Let's make it so that the client has to do as little as possible, okay? And of course, we're going to be optimizing for return on investment. So we're going to be measuring at the end of it, how is the website converting, how are users enjoying, if they're enjoying more or less the browsing experience and so on. And we started wondering, what's the best website that, you pull out your phone, what is the best website that you could, use? At the end of the day, it's an app, The perceived performance is always going to be much better. Even transition between pages, the apps have this, I would say, this, advantage of, be able to transition to the new page, show a loader, and then, load the content. It's very easy for them to do so. If we want to do it, we have to do it with a single page app. And we weren't extremely happy with the idea of, again, shipping a single page app in that sense. There are no native navigator transitions that you can implement on, mobile browsers today. So, and then we wonder, can we really get the same type of performance of a native app? Single page apps, they really closely bridge that gap. They add an additional layer of complexity. So we're at the end, and at the end of the day, probably we don't, we don't need that. So let's discard the idea of, again, a single page app, and let's dig deeper. And then, we started, looking around and seeing, what kind of websites should we, take as reference, industry leaders and what they're doing. You look at Amazon, one of the shittiest looking websites ever. Let's be realistic. Boxes with offers, yeah? You look at Wikipedia, it's text on a white background, yeah? There's nothing crazy. You look at Reddit tells you, oh, go to the mobile app, And really, if you want to browse Reddit on mobile, it's going to be 50% slower, So at the end of the day, what you really want to aim towards is the service that you're offering. You buy on Amazon because they have the best catalog. You read Wikipedia because it's the single source of truth, right? So, we're look, we don't have to be as sexy as maybe Twitter's new progressive web app and so on. We need to focus on service and build, a decent, tech infrastructure around it. And we went with what I personally call, the boring stack, which is Node, Express, React for a few client-side interactions. So imagine filters and all those things that the user applies on a search and so on. And then Webpack 2. Now, I want to dig a little bit deeper into the optimizations that we've added. On the server side, there's literally nothing. Zero, nada, desert. Okay? So the way the site works is that it's a server-side Express app. It calls an API. That API will tell it, hey, here's a list of products that you have to render, or here's the static page that you want to render, like a landing page. Or here's the product details that you want to render. So it calls this API, fetches that content back, and renders it on a template. Nothing more, nothing less. The API is shared because the mobile apps, the desktop and mobile websites use it. So we use the same API to serve all clients, but in different flavors. So maybe on desktop or on mobile, we show different fields and so on. But literally, other than using keep alive connections, between the client and the server. When I say client, I mean the mobile website and the API. It was only really that. We just use keep alive connection. We make the API as fast as possible. That's it. No real performance trick that I could tell you about. Now the client things got a little bit more, I think, interesting, especially because we wanted, as I said, to optimize for super fast rendering, shipping as less as possible to the client, and make it easy for it to run and render the page. So I don't know how many people are still stuck with Webpack 1. Could be a few if you're on legacy projects and migrating that, the Webpack config is a painful thing. We, on the path to rolling out a new mobile website, Webpack 2 was released, so we upgraded for kind of free to Webpack 2, and just with tree shaking, we just saved 20% of the bundle size. Just tree shaking, for whoever doesn't know what it is, it's just don't bundle all the dependencies, just bundle everything that your application, just the code that the application needs. So, I'm not going to import the whole of, like Lodash. I'm just going to import whatever function is actually used by the application. We said no to jQuery as much as possible. So really no need for like that, like fancy DOM API if what you're going to do is, honestly, you can manage it already with React or, like, generally I don't think, in 2017 we always need jQuery. Now, for example, we have a bunch of landing pages that our marketing team prepares. There'll be like this amazing offer and then like 3-4 products in a slider. They would use jQuery, they would include jQuery via the CMS that we give them on their own. But like on the base, catalog detail page, catalog landing page, and so on, we don't have jQuery. So if we do, it's just because our marketing, developers, it's very easy for them to use jQuery to create transitions and so on. And then beware of Lodash. I think this is one of the most important aspects of the talk, and how abstractions, okay, can really either slow you down or create unnecessary complexity on the app. Now, abstractions always come at a cost. So let's take a look, for example, at this example. We got an object, okay, and we want to create a new object based on like a few properties of our original object. I want to create a new object which just has name and age, right? So I can do it manually. Just like pull the properties that I want, or for example, Lodash gives you this amazing function pick. From the object, you're just going to create a new one picking these two properties, right? I mean, some say it's more elegant, like whatever. When I look at how they perform 700,000 operations a second versus 75 million, okay, that's quite of a difference, and that's because Lodash has like a lot of abstraction that goes into it. Check this is an object, check the path, check this, check that. And that's what you get at the end of the day. So when you don't need this kind of abstraction, just go and use, I would say, manual native, like operations. Or another thing, _get. So let's say that you have a nested object and you want to pick a property, okay, out of that nested object. Now, you can just use _get object and the path to the property, 1.3 million of operations a second. Or you can do a little bit of checking around here and there. Of course, this is probably not the nicest way to put it, and it's a little bit verbose and so on. But we're talking about 70 million operations a second versus 1.3. Like 70 times slower. And now imagine that you're doing this on a list of products. You're looping through them and applying this function. Now, I want that loop to run as fast as possible at the end of the day. Now, results may vary. There is this interesting framework that I've used for this benchmark. It's actually quite old, but works like really well. It's called Matchup. I would definitely recommend you guys to test it out. You just define, like your two functions, run matcha index.js. I will just give you the ops per second that bunch of code is able to perform. Now, one real world, I would say one real world example from one of our APIs. We've got some products, okay, in Redis. We pull those products out, and we have a bunch of attributes that we want to send to the mobile website, to the desktop website, but not to the mobile website, all right? So we store a lot of things in Redis, and then we can't pick what attributes we get out of Redis. We get the whole product object, and then we want to filter out whatever we don't give to the mobile website, right? So someone thought, okay, it's a great idea to let's just have a list of the attributes that will work for mobile, for desktop, and so on, and then we just kind of like sanitize, loop over those products, and just pick the attributes that we actually need. Now, this thing saved us around 5 milliseconds per request. I mean, when I say this thing is replacing, pick with manually building that object. 5 milliseconds per request, which don't seem so much, but when I look at it, it's like 10% of the running time that it would take for an API call at that point. So if you think, like it's really nothing. Well, like in our case, for example, that was like just that optimization is like 10% of the time that we spent, serving a JSON response. Another, I think, really important trick is, for example, this is done most of the time. We just import the whole of Lodash, and let's hope it will be fine. Whereas, you can just import whatever functions you need. Now, I don't know if, as of now, Lodash supports tree shaking very well. Back then, it wasn't. So the easiest way, Webpack wouldn't be able to to pick the right, code path for loaders. So the easiest way is at the end of the day, just, pick, like the singular function that you need without importing, like the whole framework itself. And, even when you look at functions and what they're doing, you should think like, oh, what am I really doing here? Can I optimize this little piece of code in some way? Let's see, for example, here. We've got a list of articles. We want to filter them and just pull out the ones that are active, okay? And then we're just going to map them to just change the title with another case and so on. Now, in a traditional backend app, you would just like get the active articles from the database, and hopefully the title would already be in title case when you save it and so on. This is just an example. So we filter, there's one loop, we map them, okay? 700,000 operations a second. Whereas, if you use a reduce, which does the same exact thing through an accumulator, you just use one loop at a time, So you check if an item is active. If it is, title case it and push it into my accumulator. Return the accumulator, and eventually we just get the same result back. 4 million operations a second, more than 4 times faster. Okay. Now I'm not arguing that we should be changing all our filter maps and so on to use reduce, because eventually when you look at this code, it's kind of like very clear what it does. Here, a little bit more complicated. You have to think of like, oh, why am I using a reduce, right? But at the end of the day, if there is some critical piece of code that you really want to optimize, it's like very easy. It's like right in front of us. For example, sprites. How many of you are currently still using image sprites? No one. 3 people. I don't want to hate on you. I expect more people. So the ones that are not using them, why are you not using them?
Fonts.
Fonts? Well, let's say you want to bundle like a bunch of assets, a bunch of images together. Like, are we still doing it? I think like a lot of people are still using sprites so that like we just make one connection and so on. The way we look at the problem is like, look, we can just upgrade to HTTP 2, and we kind of don't need sprites anymore at that point. I'm gonna say, like it doesn't give you like the same exact performance. I'm gonna explain it later, but just to give a primer on like how we got to sprites and why I'm advocating to like not use them at the moment. Sprites are a pain in the ass. You need to create an image. If you add a new image to that sprite, okay, reposition everything in the CSS. Honestly, like if I can avoid that, I'd be happier doing so. Now, let's say that we have 3 images that we want to serve on a web page. 300, 500, 200 kilobytes, right? In the very old times, we send two requests, and we get back just 800 kilobytes, and we use them on the page, right? But we're creating 2 connections at the point, HTTP 1.1. Now the problem with HTTP connections is that they're generally quite expensive. There's the TCP handshake. If you have TLS on top of that, that's even like slower. So like the good old rule was like try to use a sprite, combine all of them, and you just use one connection to download everything. Now the problem in this case is that this page only really needed, like these 2 assets. But like through the sprite, we're downloading unnecessary stuff, right? Now HTTP 2 changes that completely. So it creates one connection only and lets you request, like send multiple requests through that same connection. So you just download whatever is needed for this page and use it. Just one connection, no need to establish. HTTP 2 added multiplexing, which is one of the biggest revolutions in HTTP ever. So I think that's a very, good, good thing to consider when you're like, okay, do I really need to maintain image sprites for this app? I mean, not anymore. In 2017, I think you just add HTTP 2 and you're good. There's one thing where sprites are still going to be, I would say, better. It's compression. Like if I compress, like each image separately, what I'm gonna save less than if I combine them all together, and I'm gonna compress them. But that difference is very negligible. Like compression formats work better when you feed them a lot of data. Okay, so if you compress each image separately, they're not going to be as effective. But the difference is right now, I would say, literally negligible. So I would say, like we don't really need to. React. So as I was mentioning, we use React on the client for just like a bunch of like client-side interactions. And the idea is, okay, let's take React, but without a lot of the sauce that React comes with. So you got React Lite, you got Preact, 95, 99% of API compatibility, at a fraction of the size. In our case, we eventually decided to use React, super small. It has worked like really well so far. So we literally use React only in dev, and then like the production build uses React. So this, I would say, screenshot like super slow, I'm sorry, but then like we started playing around with CSS animations and so on. So like once a user add to the cart, we show things popping in and out of the site. And I think one really interesting thing, let's see if the connection will be good to us. So right now what you're going to see is a transition between a catalog page when you show a lot of products to a product detail page, like the detail of that product. And that's happening, with server-side rendering. So we click on a product, and this is all server-side rendering. There is no flickering. The browser is not flashing you anything. It looks like, like this thing is, like a client-side transition, right? But it's not. What we do, we load an overlay that has the same header, and a bunch of images. And then when the browser receives the new DOM from the new page, it's server-side render, right? When the browser receives it, it's smart enough to say, oh, I don't have to re-render the same thing. This stuff is the same from that page. Like a very small trick, but it gives, the user the impression that, like the transition happens extremely seamlessly. There is a proposal by Jake Archibald. He's one of the front-end engineers working at Google on Chrome and web standards on, how to implement navigator transition between pages. It's unfortunately something that is still up in the air. Google experimented with a prototype back then. I think, like right now, if you want to do something of this sort on, like with server-side rendering, you can really only do these kind of things when, like you keep the DOMs, like very similar. So when a new page comes in, it doesn't re-render the whole thing. It just re-renders part of the page. A bunch of optimizations at the HTTP level and how we load assets and so on. So I want to make sure we pre-connect as soon as possible. We create a connection to our CDN. We could also use server-side push at this point. Pre-connect also works well. So as soon as the browser says this link, is like, okay, I have to connect to this. I have to create an HTTP connection to this, domain, to this address. And later on, we'll have links to the JavaScript, CSS, and so on that are going to be using the connection that this guy instantiated. So this is so that we can instantiate connections as soon as possible, like as early as possible. Another thing, for example, is preloading CSSs in a way that we don't block the page. So we have a link in the head with a route preload to the fonts. Okay, fonts generally big file, painful file to load. We say, I want you to preload it as style, and then when this is loaded, change the route from preload to a style sheet. And that's going to be applied on the page automatically by the browser. And in this way, this is how you do a sync loading of, like CSS and so on. For example, this page, you load it, the CSS hasn't come yet, it's just a white page, and boom. The page is already rendered, so I'm loading the page, and the green background is what comes from the CSS that gets loaded, asynchronously. Okay? This way you can offload, like things that, like fonts that take a lot of time to load, so that you can still render the page. And when those are going to be loaded, you apply additional styles. Now, I don't know if you want to really load your whole CSS asynchronously at that point, but for example, fonts are a very good piece where you can apply that. Pre-rendering as well. Imagine that you're on a page on Amazon, like one of the product listing page. You have pagination, so you have page 2, 3, 4, 5, right? Now, we would like to pre-render for the user the next page. It's going to screw a little bit with his mobile data plan, but at least it'll lead to a faster user experience. What we do is, once the page is loaded, okay, once everything is finished, all the JavaScript have run and so on, we create a link with a pre-render with the URL of the next page, and then boom, we bammed it into the DOM. Now the browser knows that, oh, I have a pre-rendered link. When the user is not interacting a lot with the page, when I have CPU cycles to use, I'm going to pre-render that page. The browser doesn't always do it. It really depends on like the interactivity between like the user and the web page. So then what happens when you navigate to the next page, you will see that some of the assets are already cached. Okay, because the browser in background has like preloaded a bunch of stuff. Okay, so when the user actually clicks that page, like a bunch of things will be coming out of the cache. You could do this with service worker and so on. Yeah, I think though, for example, implementing with a service worker is a bit more painful. This is literally like 4 lines of code. Split assets. I think this was also, like traditionally we bundle everything in one JavaScript file, and we're like, okay, fine. Whenever it changes, it's going to invalidate the cache. Users will re-download it. This time we experimented with, splitting assets by, let's say, page type. So, like wish list page, search page, card list, and detail page. And then we have 2 things tracking an app that are kind of shared across all pages. And of course, we create through Webpack a bundle with all our vendor dependencies, because they're not going to change as frequently. So probably that vendor bundle is like the same since the last 6 months. And then what happens in our index HTML, you include like a bunch of assets, okay, vendor, the app, and then we have a block that each page type can extend. So for example, the detail page adds its own assets, which is detail.js. So we just load on that page the JavaScript code that's necessary to run that specific page. I think like you still use less bandwidth. There's a good hit rate in terms of cache. It's not as good as probably like having everything bundled in one file, but it makes it easier. Like because you reuse. Let's say that the user visits 2 different pages, he will have to download an additional bundle. Let's say from the catalog page to the detail page. But still, like it's a very small chunk of code that comes down. I think like the rule that we've given ourselves is like try to stay as close as possible to 100 kilobytes, no more, no less. Now, if you browse Namshi, open the DevTools, and see how much JavaScript we download, it's around 100 kilobytes. There is a bunch of more things there for tracking and marketing. Our marketers always I like to add JavaScript snippets to track and like screw with the user. And like so it's a little bit more than that. But let's say the core product is like for each page is less than 100 kilobytes of JavaScript. Which is, I think, very close to, eventually what Amazon does. Same thing. They do less than like 10 requests and, 100, 150 kilobytes of data. Now, the results, in our case, I think, like I'm just going to go briefly through a bunch of numbers. So the average document content loaded time, it's, it's less than half of what it used to be. Now, again, if 1.9 seconds seems still high, you still have to consider that you have users on 2G or like very unreliable connection. We're talking about only mobile connections here, so and not just in the city. Then the bounce rate, which tells how scared your users are of your website. Like you just open a page and then close it right after because they're not interested and so on. The bounce rate was down like 14%, which I think it's because like when you load things faster, when like the user doesn't have to download lots of JavaScript, everything is almost pre-rendered for you. Like it's more likely that the user will not have any problem. There's like a slow connection whatsoever. Everything comes with the HTML, so you can already see all of the page, right? The average session duration, I think this is very interesting, went up by 40%, which means eventually that people enjoy the browsing experience much more. So they're more likely to stay on the site and not have troubles. The way I explain it is that I think like with a single page app you could have like a bunch of like problems executing that JavaScript on the client. Again, native browser on Android and all this kind of things tend to screw up the experience, right? And the master of all the, I would say all the metrics, conversion rate was up like 30%, which means if we were making $100 a day, now we're making 130, which is just from the mobile website, which is I think a very good outcome at the end of the day. What we're looking forward to right now, like I think there is a bunch of interesting things. I think I just added 2 of them. gRPC. So for those of you who don't know gRPC, it's basically an RPC framework built by Google. That's how most of Google's services talk to each other. So I think it's a very good way to tie up your client with the server through common like definitions and specifications. So you write a spec, and then gRPC will generate an SDK for the client to consume your API. sort of, you know, an XML RPC way back then, just built by Google, so probably makes sense. The problem is that currently it's still not available in the browser. They've been doing lots of work to implement gRPC web. So I think within the next 6 months, it should come there. And at that point, we will be able to talk from the client side to services that speak gRPC. Another thing that I think it's really interesting, and we don't need a single page app to implement is like push notifications. We've picked, of course, Firebase. I think it's the best tool for these things. We are currently developing them. It would be really interesting to see. There is a venture, so Google has these use cases that they publish on the developer blog. There was this use case by Jumia, is an e-commerce retailer in Africa that said, we almost doubled up, engagement rates with users through push notifications. So I think that's something that we'll be very, very, very happy to experiment in the next few weeks. We're closing down on development. And then CSP, which is what we're talking about in the other room. I think that's also something we're really heavily experimenting with. I think it's a very important security feature of the browser. We rolled it out up to some extent. I would really recommend to go and see the blog post by GitHub. They have a series of 2 blog posts of how they implement CSP right at the beginning and then how it evolved. I think it's a super important security feature for everyone that develops apps with JavaScript on the client. And then, look, my favorite part of the talk, like the final, nerd advices. We've been going through like 3 apps. So I think, I've got a bit of experience on like how to screw things up. I like to see, like other people not making the same exact mistakes. Really, act upon what moves the needle. Don't think that the best, the most shiny, the shiniest user experience will mean, you double your conversion rate. Apply the Pareto principle. What Pareto was saying, with 20% of the effort, you get 80% of the work. Now, if you want to get the last 20%, you have to put 80% of the effort, which is the same metaphor that we use in software development time. To get to 80% of the project, just not to 20% of the time. So I would really, recommend just like do what you think gets you there the most, and then the last bit, when you want to be perfect, you probably won't need it. Hot technologies, like a lot of times are overrated. Again, quoting Jake Archibald, he talks about caching in service worker land and HTTP. Eventually, if we're using, like service worker cache to cache assets, out of like JavaScript and CSSs, it really doesn't make sense. You can quote me on that, because the HTTP cache spec already does that for free. You had a header, cache control, whatsoever, and the browser will cache them without any issue. Service worker can help you with a lot of other, dynamic caching techniques, but most of the time you really won't need it. And to have like a good implementation at the service worker level, what Jake says is, you need to get HTTP caching right to begin with, and then you can start experimenting with service workers. Solve problems on the right layer, which is kind of sarcastic. This is a quote from the AMP project, a very, I would say, again, controversial project on how to make the web faster. What they tell you is, don't just put things on the client. When it could be that the user experience is much better served with server-side rendering. There's no rule that, now we have to push everything to the client because that's the way to do things. You have to measure, you have to benchmark. If it's simpler to keep it on the server, just keep it on the server. And at the end of the day, servers are, I hear a lot of people saying, but client-side rendering is so much faster, yada, yada, yada. Servers can still be pretty darn fast, if you use just a bunch of, good, common sense. For example, as I told you, as I was speaking earlier, we've got, the client, the phone that connects to our front end, the mobile website, and that guy connects to an API to fetch, a JSON with the products, a JSON with the landing page, a JSON with the product details. So, the mobile website relies on another API that feeds it the data, right? And this is, what our monitoring tool shows. So, first of all, the average performance, the average request time is around 40 milliseconds, which is, I would say, very decent. Now, average make it for a really terrible metric. You will want to look at percentiles, because an average will not tell you if, 50% of your users receive everything very fast, but, the last 10% takes 10 seconds to receive content, the average will still be quite decent, but it won't show you where the real problems are. I would say percentiles are much more interesting. So for example, the median here shows that 50% of the requests are served within 20 milliseconds. And I'm talking about, like full-fledged HTML page that can be rendered by the browser, 20 milliseconds. Nothing more, nothing less. You have to add latency. The user maybe is connecting from, like this country, the server is somewhere else. But, like the app itself, like half of the traffic goes out within 20 milliseconds. And then the 95% of the traffic gets served within 100, 120 milliseconds, which I think is still, this is the 99th percentile. But, I think it's still, like pretty good. I would take, this kind of server-side rendering any single day. 45% of the traffic gets served within 10 milliseconds. So this is a histogram that shows you what percentage of the traffic gets served within what time frame. So you got that point, another 10%, 20, another 8% at 30 milliseconds. But this is really what gets me like super hyped. That like almost half of the traffic goes out within 10 milliseconds once it reaches the server. That was kind of it. I think well, pretty much on time. My name is Alex. I'm gonna post again Twitter handle in case you missed some bad words from me. Again, I work in Namshi as CTO. I try to tell people what to do in a very bad manner, because then we screw projects up, as I was saying. You can, read a bunch of my ramblings on odina.org. Lots of, very stupid things. Well, thank you very much for having me.